Okay. Okay, right. So for this lesson today, we ordered a pen. All got a pen? Pen. Yep. Pen. Right. So we're just going to review parallel lines today. So just to start with reviewing some terminology. So what do I mean by the word parallel? Good. Two lines that will never meet. So you can just like do a rough drawing. Now, obviously, it's really when you do it by hand, it's hard to be really accurate. So to kind of cover yourself, you put two arrows going in the same direction to show whoever you're doing the drawing for that these two lines are parallel. Okay, so that's kind of your way of showing it. Now, transversal is a line that cuts through those parallel lines. So that's your transversal. Okay. And you can have multiple transversals cutting across parallel lines, right? So any line that cuts across them is a transversal. The other thing to say about lines is lines theoretically are infinite. So what I mean by infinite is that they go on forever, but we draw them within a certain area. But if you needed to, for whatever reason, if you wanted to work stuff out, technically you could extend every single line further than what's already drawn. So you could get a ruler and extend them for whatever purposes. And so you can do that for all your shapes as well. So like a triangle, you can extend all the sides out, all the edges out if you need to as well. Okay, so that's the first thing. Now, we're just going to run through the types of angles, and then we're going to do a few practice questions to show them. So when you have parallel lines, we've got three types of angles, and these are basically tricks to help you to be able to find what the angles are more quickly. So instead of like using your supplementary and complementary angles each time, you could use these rules to work it out. So we've got corresponding angles, and we say that they're equal. So the way I kind of describe that is you've got your two parallel lines, and then you've got your transversal cutting through. Okay. Then if you circle the four angles where the transversal and the parallel line meet, like you've always got four angles. Okay. I can do it for these two. So the one transversal will have groups of four angles wherever it cuts with the parallel line. So here, in this, my little sketch over here, we can say that whichever ones are in the same position, they are corresponding with each other. So for example, in this top group of four, if I just number these, 1, 2, 3, and 4, so that's my top parallel line with my transversal. In my bottom group of four, we can say that's in position 1, that one corresponds to that. 2, 3, 4. So they're corresponding, which means they're the same size as each other. So it's a time saver for you. But it has to be along the same transversal. If you have two transversals, you can't use that rule. You can't say they're corresponding. Okay, only along the same transversal across same set of parallel lines. Okay, so the other trick that sometimes they use is the F shape, but I hate that one because it requires you to be able to flip F backwards and forwards in your brain. So I just prefer to use the group of four rule. But if you want me to I'll just quickly kind of give a summary of what the F thing is. So if you draw an F in this direction, the ones inside like the corners of the F, they're corresponding. If I turn the F mirror image, so I'll just take that back, like this, backwards F, in the corners of the F, they're corresponding. Then if I go upside down F, like that, these two in the corners, they're corresponding. And then the one that messes with people the most is the backwards and mirror image F, the one going this way, they're corresponding with each other. So that's where that F thing comes in if you ever come across it. But I prefer the group of four thing. That's easier for me to understand. But some of you may prefer to use the F thing as well, depending on what you've seen. Okay, so there are two ways. But, if corresponding doesn't make sense to you, there's always the straight, supplementary and complementary rules and other things to help you as well. Now, alternate angles are equal. So this is the Z-shaped one. So a little bit easier. You've got two parallel lines. So these two parallel lines. You've got the transversal cutting through. The two alternate angles are on the inside of the parallel lines, on the opposite sides of the transversal. Okay, so here we've got C and then we've got D as alternate angles. And we also have a second set. So we also have, I can also, if I do a little sketch of this one again, parallel lines, we also have a Z going backwards this way. Okay, and so these two are also alternate. So this one is also alternate to this one. So inside the transversal. Okay, so alternate angles. So forward Z, backwards Z, a bit easier to remember. But what basically inside the parallel lines, opposite sides of the transversal on the inside are the same. Okay, alternate angles. Is this kind of coming back to you? Yeah, sort of. Then co-interior. Now those, so corresponding and alternate are for angles that are equal to each other, right? Co-interior, slightly different. The key thing, and I'd probably highlight this, is that they add up to 180 degrees. Okay, they're actually supplementary to each other. So we use the C rule to work to show this. So inside your parallel lines, if you draw a C that cross and the like spine of the C, I don't know what you call that bit. This the top part, the side of the C is the transversal, and then the top and the bottom are the parallel lines. Are we okay, kids? Yep. So the two of them inside add up to 180 degrees. So let's just say I've got what do I call this one? 60 degrees here for C. That's totally inaccurate. No, let me change that. Let's make it 120 degrees. Okay. What's D going to be? So sorry, I changed my mind. So C is 120. D will be 60 because 120 plus 60 is 180. Okay. We can also have a backwards C. So I'll do a little sketch down here to show you the backwards C version. So there's my parallel lines. You can also have backwards C going like this. And then my two angles inside, there and there, they're co-interior, and those two add up to 180 as well. Okay, so lots of little tricks to help you to remember. So commonly people think they're the same. So just make sure with co-interior, they add up to 180. That's the key part of that. Now there's one more which I did not put on there. I forgot to put it on there. So I'll just draw it and you tell me if you remember the name of it. So it goes like this. Yeah, what's it called? Vertically opposite. So when we have, so if you want to just squeeze this in somewhere, if you can find somewhere on your little sheet. So vertically opposite. So basically it's any two lines that cross over with each other, the opposite angles are equal. So maybe I'll just say two lines that intersect or cross over have equal angles. Angles opposite to each other. Opposite. Hopefully that makes some kind of sense. So these two are equal and then these two are equal with each other. And that applies to any lines that cross over. Okay? So with a combination of those rules and the complementary, supplementary thing we did last lesson, this should be able to help you solve a lot of these problems. Okay? Any questions about this first bit? Gone through it really fast, but it's when we use them, that's when it's a bit easier to talk about them. Okay, so example A, so example 1 says, decide if each diagram contains a pair of parallel lines and give a reason. So we've got 80 and 101 here. So what type of, just based on their position, what rule will we use to test it out? Co-interior, yeah. So we'll use this idea to see if these two are parallel to each other. So the 80 and 101. Now, are they? No. Why not? Yeah, they don't add up to 180. So 101 plus 80 is equal to 181 degrees. So therefore, no parallel lines. Just give some reason. Okay. They just want some kind of justification to say why not. Okay, the second one. So we've got 44 and 44. And we've got these two lines there. Are they parallel? Yes. Why? What's the type? Corresponding. So yes, because they are corresponding angles. Okay, what are the birds screaming about? Yeah, they're mad. Yeah, they're crazy today. All right, so C, we've got 110 and 110. These two will be the parallel lines that we're looking at. Are they parallel? Yes? Why? Good, yes. So yes, because they are alternate angles. The angles are alternate. Alternate. Okay. Okay, good. Okay. All right, should we keep. Any questions? All right, over the page. Oh, sorry, go back. Yep. Okay. All good? Yep. All right. So over the page, we'll keep going. Find the value of each of the following numerals. Give reasons for your answers. Now, there can be multiple answers, or multiple reasons. One answer, but multiple reasons. So, firstly, what's A? And why? Good. So there we've got two lines that intersect. A is vertically opposite. Okay. Right. Then from there, what's B going to be? So that's 110. 70. Yep. What's your reasoning? Co-interior. Good. So we've got a co-interior here. So B is equal to 70 degrees because it's co-interior. Okay, good. Now, how about B? B, let's look at question B. What's A going to be? 112? Yes, why? 180 take away 68 is 112. How do we get to that though?
Because you have to do I did B first.
Yeah, okay. So B is going to be 68 degrees. And what's the reason for that? Yep. It is a straight angle. Yep. We'll come back to A. So B is corresponding. Okay. So if you look at the group before, they're in the same position. And then A is because there's a straight angle between A and B. So 180 take away 68 is 112. So we can say that it's a straight angle. But there are some other people may go a different way. They may go, this top one here is 112, and then it's alternate to A. So it depends on your process to get to that. So as long as you can provide a reason. Okay. Maybe I should say straight with B degrees.
So if you're answering something and then you just like think of it in your head, you just
Yeah, we'll just write an explanation so we know why. Yeah. Whichever process you use, try and show you did it. Okay, I want to get to these ones. So C and D are a bit more bamboozly. So with C, any suggestions on how I could do C? So we want to find all those letters. So maybe we start with U. Yep. What do you got?
So for U, it's co-interior.
Yep.
With 70.
Good. So U is co-interior with 70. So there's my parallel lines, and I can do a backwards C. So U is going to be how much? 110, yeah, because it's 180 minus 70. So 110 because it's co-interior. Good.
Then if you do V, and the way you figure that out is the angle next to 70 that's like blank.
Yep.
That is alternate to U.
alternate to U. Yep. Yes, it is. Yep. So U is alternate. This is also U. I'll write these in. So that's 110. That's 110. Yep.
Which means you can use the revolution idea to figure out what V
Yep.
is.
You can use the 360 rule.
Yeah.
Does anyone have another method? There's multiple methods for this one. Yep, go.
Can you 180 minus 130?
Yes, you can do. There's a straight angle here. So you can go 180 minus 130. Any other methods? No, that's it. Yep.
Is there another one?
Oh, I don't know. Maybe. See if anyone come up with something else.
Do you just do W?
You can do W first. So you could work out W.
Yeah.
So W is going to be what? Because that's also co-interior there. So what will W be? 50, yeah. So there's another co-interior. And because you know what W is, what's the relationship with W and V? So it's alternate with W and V. So there's your Z there. So then you can get to W that way, V that way as well. So lots and lots of reasons. So many ways to do it. So whichever reason you use, I'm just going to write alternate. But if you wanted to alternate LTNATE, as long as you justify it any way you want. Okay. So many ways to get to the same point. Okay. How many more have we got? Oh yeah, one more. Okay. D. Tell me, how can we work out what X is? Well, actually, I'll give you a minute to work it out. Oh. No, okay, go on. Okay, we'll just do it.
So you do the corresponding angles with 60.
Hang on a minute. There's no parallel lines in this one. So what's the other name? What's the one you're thinking of?
180.
Oh,
the
180.
180.
The 180 thing?
Yes.
Yep.
So you 60 plus 50.
60 plus 50. Where's my other 50?
No, 60 on the bottom and 50 on the bottom.
So we've got 60 and 50 here.
Yeah. So the angles added to 110.
Adds up to make 110. Yep.
Plus 20.
So you want to find this one here. Is that what you're thinking?
Yeah.
Yep. So 60 plus 50 is 110. And so that will be how much? 70. Good. Beautiful. Yes, because then we've got to work out X. So then what plus 20 makes 70? 50 degrees. Nice. I like that method. Any others?
I did a more complicated version of that.
Yep. Heidi went complicated. Go on.
Yeah, I just realised. But I figured out that they're vertically opposite.
Yep.
Right. So if one half is 50.
Yep.
We look at the 50 and 60.
Yep.
Then each side of the vertical opposite has to be 110.
Yep.
So then you can use that to figure out.
Yeah, so you went the backwards way. Yeah, so you can say the other thing that people might have done is gone, yeah, that's 50, that's 60 as well. They're vertically opposite. And then same idea that way. So you can look at it that way too.
And then I did the revolution.
Oh, you do revolution. Oh, wow. Yeah, okay. Went the long way. That's all right.
right.
Okay, good. Excellent. Last one. Add a third line to help find A, B, C in this diagram. I know you do this in year 8. I remember teaching this. All right.
No, we had a test on.
Oh, yeah.
One question, everyone got thrown with it.
Yeah. So with this one, we want to add a third line. So we've actually, anyone know where we put it? Maybe we'll start with that. Yep. In the middle, yeah. So we stick a third line. Oh, I'm going to get a real line. You want to put a third line through the middle where it cuts through B perfectly. Oh, no. Computers don't like me. Oh, I'm just going to have to draw it by hand. This is bad. Okay. So here's my attempt. Oh, God. Okay. That's shocking. Anyway, so get a ruler and do a nice line. Now, all right, from here, what can we do next? Go.
You do the alternate angles with 50 and 70.
Good. We can work out alternate angles. So we've got 3 parallel lines. There's an alternate angle there. So that one there, that part there is going to be 50 degrees. Then we have another alternate angle down the bottom. What color we'll do it? This one. Here's another one with a backward Z, alternate angle, which makes this one 70. So then my angle ABC is equal to what altogether? So angle ABC, which is the whole thing, is, so 50 plus 70, which is equal to 120 degrees. Okay. Yeah. All right, cool. So that's the gist of it. So hopefully, I think that's it. Yep. That's the gist of it. Does anyone have any questions about any of these? So you can also, so don't forget, you can include what we did last lesson, like use all those ideas as well as what we looked at today to go over it. So to finish off today, you want to finish off Monday's work if you haven't already. And then this is 7B. So this basically needs to be done by the start of next term. So we'll see if you can finish it today. We've got assembly tomorrow. We don't have maths. Yeah.